Picture you're running a bustling restaurant with several different dining areas. Rather than assigning a separate waiter to each room, you've got one superstar waiter who can take orders from all the rooms using a shared pathway. This is similar to how VLANs operate when they need to stretch across multiple switches. Now, trunk links are like that shared pathway, carrying traffic for all VLANs over a single physical connection. The magic ingredient making this possible is IEEE 802.1q, the VLAN tagging standard. It slips a 4-byte tag into the Ethernet frame, indicating which VLAN the frame is part of. Without this trunking wizardry, you'd be stuck running a separate physical cable for every VLAN between switches, like having a different waiter for each room. That would be inefficient and a bit of a logistical nightmare. But with 802.1q trunking, a single gigabit link can juggle hundreds of VLANs simultaneously, keeping the whole operation smooth and efficient. Let's dive into how IEEE 802.1q works its magic. It slips a 4-byte tag right between the source MAC address and the ether type field of a standard Ethernet frame. Think of it as adding a secret ingredient to your favorite dish. It transforms everything. Now focus on the first 2 bytes of this tag. They're called the Tag Protocol Identifier, and they always say 08100, which is the universal way of announcing this frame is 802.1q tagged. Then come the next 2 bytes, where things get interesting. You've got a 3-bit priority code point for quality of service, a 1-bit drop eligible indicator, and a 12-bit VLAN ID. With those 12 bits, you can have VLAN IDs ranging from 0 to 4095. But here's the twist. Like the first and last spots at a concert, VLAN IDs 0 and 4095 are reserved, leaving you with 4094 VLANs that you can actually use. So, you want to set up a trunk port on a Cisco switch? First, you'll need to change the port mode to trunk. While you're at it, you might want to specify which VLANs are allowed and set a native VLAN. Now here's where things get interesting. There's this feature called Dynamic Trunking Protocol, or DTP. It's like autopilot for trunking between Cisco switches. Sounds convenient, right? But hold on a second. It's a bit like leaving your house keys under the doormat. Not exactly secure. So you'll want to disable it using Switch Port Non-Negotiate. For extra peace of mind, make sure DTP is turned off on all ports and manually set each port to either trunk or access mode. Also, change the native VLAN from the default VLAN 1 to something unused. This helps fend off VLAN hopping attacks, which is basically the network equivalent of a stealthy ninja slipping past your defenses. Dynamic Trunking Protocol, or DTP, is like a speed dating service for Cisco switches, effortlessly setting up trunk links between them. There are 5 DTP modes you need to get familiar with. First, there's Dynamic Desirable. Think of it as the social butterfly, always on the lookout to form a trunk connection. Dynamic Auto, on the other hand, is more like the introvert at a party, not making the first move but happy to jump in if someone else does. Trunk mode is the straightforward one. It just goes ahead and makes the port a trunk. End of story. Access mode is its polar opposite, keeping everything strictly in access mode. Then there's Non-Negotiate. Picture it as the lone wolf, turning off DTP entirely. Now, how do these modes get along with each other? It's like the compatibility chart of networking relationships. Put trunk on one side and dynamic auto on the other, and they'll form a trunk connection easily. Pair dynamic desirable with dynamic auto, and you've got another successful match. But mix access with dynamic auto, and you'll stay in access mode. And if access meets trunk, it's like trying to mix water with oil. They just don't blend. The access side remains in access mode, and no trunk forms. It's one of those quirky things you'll need to remember. Trunking can be a real minefield, so let's tackle 5 common traps that make network engineers sigh in frustration. First up, the native VLAN mismatch. Imagine you've got 2 restaurants with identical names on opposite sides of town. One serves pizza, the other sushi. If the native VLANs on either end of a trunk don't line up, traffic meant for one VLAN ends up in the wrong place. Sure, CDP might give you a little heads up about it, but don't brush it off. It's a security issue waiting to happen. Next up is the dynamic auto conundrum. Picture 2 drivers at a 4-way stop, both politely waving the other on. If both switches are set to dynamic auto, nothing happens. No trunk forms. You need at least one side to take the initiative. Now let's talk about the 802.1q modification. This protocol tacks on an extra 4 bytes to a frame, bumping your maximum frame size from 1518 to 1522 bytes. The fourth trap is the infamous allowed VLAN list. If a VLAN isn't on this list for a trunk, it's like trying to get into an exclusive club without being on the guest list. You're not getting in. Lastly, there's a quirk on older iOS systems. Before setting the mode to trunk, you must specify the encapsulation with switch port trunk encapsulation .1Q. Fortunately, newer switches are more forgiving and default to 802.1Q for you. So there you have it, 5 trunking traps to steer clear of. Remember these, and you'll avoid many headaches down the road. That's the lowdown on 802.1Q trunking. We went through the frame tag structure, talked about the native VLAN, touched on DTP modes, and walked through trunk configuration. Now head over to Courseiva.com for some CCNA practice questions. You're doing great. Keep going.